All right, hi everyone. My name's Jon Mease, and I'm looking forward to having the chance to talk with you all about our work on version 3 of the Plotly Python library. So to quickly introduce myself, I did my undergraduate studies.
Would you be willing to use the mic?
This one, sure. I'll turn it on though.
Try now.
Testing. This one on?
Check one.
Yeah, there you go. I just need to hold it a little closer.
Sure. All right, give it a try. So yeah, I did my undergraduate studies in physics and mathematics at Millersville University, and my graduate work in computer science at Johns Hopkins University. I now work as a data scientist and software developer at the Johns Hopkins Applied Physics Laboratory, and one of my areas of interest has been working on applying what I see as some of the best of the PyData ecosystem to some of our challenging analysis problems. And PyData DC actually has played a role in that process about 2 years ago, I guess exactly 2 years ago. I attended PyData DC. It was my first data science related conference, and I had a really great experience talking with some of the maintainers of different projects, and was really inspired to kind of get more involved in my own learning and in the different communities. And I was so inspired that I got involved in some open source projects. I did some contributions over the last 2 years to Pandas and Dask, and then Plotly. And over the past, about 4 months ago, I actually became the maintainer and lead developer of the Plotly Python library. And I'll talk in a minute about how that fits into the rest of the Plotly ecosystem. So, goal is to give you sort of a whirlwind tour of what we've been up to this past 4 months. And I'm going to start though with some background. So Plotly.js is the JavaScript, is a JavaScript data visualization library. It's based on D3 and WebGL, and it supports a really wide range of visualization types. It covers a lot of financial, statistical, geographic use cases, and even some advanced three-dimensional use cases. The library was initially developed by the company, Plotly Technologies Incorporated. It was part of their, initially part of their commercial visualization products, but it was open sourced in 2015 under the MIT license, and it's been in active development on GitHub ever since. So just to be clear up front, everything I'm going to show you today is based entirely on, or is entirely open source technology. It's self-contained, it works offline, it doesn't require an account, and you can use all of this on your own servers. There is integration with some of the Plotly cloud services. That's all optional and not what I'm talking about today. All right. So Plotly.js is a declarative library, and in this case that means that every plot is fully defined by a JSON specification. So you don't need to know about the order of operations to represent a plot. It's represented declaratively by this JSON specification. And in addition to that declarative representation, it has a really nice API for updating plots after they've been created, and then for receiving callback events in response to user interaction, things like hover and selection and click, those kinds of things. Now the Python library. So Plotly.py is the Python library with the job of generating these JSON specifications for plots. So before version 3, this was a one-way, one-time thing. The Python library would build up this JSON representation and it'd be passed across to the JavaScript library, and that would be displayed either in a notebook output cell in the Jupyter Notebook, or it could be displayed in a standalone HTML file or uploaded to one of the Plotly Cloud accounts. And there wasn't a way to get the information back from the JavaScript side back to Python. There wasn't a way to get access to the interaction events like selection information. So that's where the ipywidgets framework comes into play. So ipywidgets and the Jupyter widgets side on the front end provides a really powerful set of building blocks for supporting the two-way synchronization of properties between the Python backend and the JavaScript front end. And so what I started with is I worked on creating a new ipywidget Python library for Plotly.js. Initially, I did this on kind of the outside as an experiment, and then I showed this as a prototype to some of the Plotly folks, and they were really excited about it. And then I worked with them to get it integrated into Plotly.py upstream. And that integration then became version 3 of the PolyPython library. And that's what we released back in July, I believe it was. So that's as far as I'm going to go into the sort of technical details of how this synchronization and how these updates work. I did write a paper for SciPy this past summer. So if you are interested in more about how this works, or if you're interested in doing this for another library, writing out this kind of widgets wrapper to get this synchronization, you can check out this paper that I wrote this summer for SciPy 2018. All right, so here's just a quick summary of some of the features that were introduced in version 3. I'm going to go through these and then do some demos, and then show you, talk about what's happened since then. So the biggest piece is this ipywidgets integration, and this has made it possible to display plots in the notebook and then update them in place after they're created. And we have a new imperative property assignment API for doing that. There's now great auto-completion and inline documentation across the entire Graph Objects API. And there's also much more robust property validation, and the error messages are really more precise and a lot more helpful. And thanks to the ipywidgets integration, now it is possible to get information back from the JavaScript side. So we can support registering Python functions to be called in response to interaction events like clicking and hovering on your plots. Finally, this version takes advantage of some of the nice optimizations in the widgets protocol, so that when you're working with large arrays, they're now transferred in binary format across from Python to JavaScript, so you can get a much faster interaction with working with arrays, like doing scatter plots like up to 1 million points is tractable now. All right, so I'm going to jump into a couple of demos. Live code, let's see. Okay, so this is one of the many cars data sets. This one has information about efficiency, fuel efficiency, horsepower, torque for a data set of around 5,000 vehicles, maybe between 2009 and 2012. And then to make this a little more interesting, I did some simple web scraping to pull down the first Google image search result for each of these descriptions. So here's what it came up with for the 2012 Chevy Camaro Coupe. I'm going to make my first figure now. So this is going to be a torque versus miles per gallon scatter plot. And to start off, I'm going to show you the declarative nature of plotly.py by creating this figure with a single trace to start with. So you can always define the entire figure in the constructor. Every property that plotly supports, you can put it in the constructor and get the whole thing at once. And now I'll show you later on how you can iteratively update them as well. So this figure widget class is a new class we introduced in version 3. And it is itself an ipywidget. So what that means is when you dump it out to the notebook, its display representation is the plot itself. So you don't need to use a special function to display the plot. It renders itself in the notebook. All right, but I forgot to label anything on this figure. So I'm going to take care of that. I could go back up to the constructor and add some new layout properties to set the labels, then regenerate the plot and look at it again. But I want to show you the new property assignment API and how you can do that with an already constructed plot. So here I have the figure object, and now I can show you how you get completion across this entire object hierarchy of properties that are supported. So here, I accept completion on title. I can use Shift Tab to pull up the documentation string for that property. Here I can see that title is a string. It needs to be specified as a number, or either a string or a number. And then I can assign to it. I'll assign to it torque and fuel efficiency. And then immediately, the plot is updated with the new title. This happens automatically. There's no extra step of pushing the change to the notebook. This is detected in the assignment and updated right away. And while I was looking at that completion menu, I noticed that there's another property there called title font. So I want to see if I can use that to change the size of the title. So I'll accept title font, trigger completion again, and then look for size. Here I can use Shift Tab to find the description. This is the property that sets the font size. And I'd like it to be a little bit larger than the default, but to do that, I need to kind of understand what the default is. And in past versions of poly.py and in a lot of plotting libraries, it's not always easy to find out what the defaults were that were chosen for you and how you can adjust from that. But with this two-way synchronization, we're actually bringing the properties that were chosen by the JavaScript library back to Python. So you can just access this property and see that the default value that was chosen was 17. So I can bump that up to make an informed decision of how I want to change it and move up to 22. And now I have a larger title. All right, and then, just for fun, change the font family to Rockwell. All right, so you can already see that it's getting a little bit cumbersome to scroll up and down between the code that I'm doing to update the plot and the figure. So I want to show you another, one of my favorite features about Jupyter Lab is that I can right-click on this notebook output cell and accept the option for creating a new view for this output cell. This will open up a new tab in Jupyter Lab that has only this output cell, and I can drag this around and place it, arrange it where I want in the notebook. This is a fully responsive. I can resize things to get the arrangement the way I want. Because this is built on ipywidgets, these views are actually two views of the same data model. So I can do things like pan in one and zoom in the other. These are linked together. So I can work interactively on this view to the side as I scroll down my notebook without having to scroll up and down, but the plot's still there, so you still get the full linear, reproducible workflow of your final notebook. So it's a nice, I think, best of both worlds there. And now I have the side view. I'll set the x-axis title with property assignment. Notice that updated right away. I'll do the same thing for the y-axis. And then just to show again that these stay in sync, I'll scroll up and see that both the x-axis and y-axis titles were made in both places. All right, so the labels are looking good. Now let's look a little bit more at the data itself. So if I zoom in on a chunk of this data set, I'll see that the points are quantized, like these discrete jumps in the miles per gallon and the torque as well. So I can't really tell the real density of this distribution of whether how much overplotting is going on. So one way to work with this is to apply a slight random jitter to these points, and I can do that. First I'll grab a reference to the scatter trace. So scatter is the first trace in this figure. And then with that scatter trace reference, I can update the x and y values with property assignment. And again, immediately I get this change. I can see the jitter applied to the plot. And with that, I can tell that I do have an overplotting problem. I have all these solid regions where I'm not able to understand what the density is and how relative to other regions in the data set. So one way to work around this overplotting problem is to add an opacity to these points. So I can go back to my scatter trace, use completion to find the marker, and then look for the opacity. I can check the documentation string, see that the opacity needs to be a number. It needs to be between 0 and 1. And then I can evaluate it to see what the default opacity that was chosen for me by plotly.js, and that was of opacity of 1, so fully opaque. And then I can assign to it, I'll assign it 0.2 to drop that down. And that helps a good bit. I can start to see the denser regions more easily, and I'll look at the size as well. I'm going to shrink the size a little bit so I can evaluate the default size, see that was 6, and then I'll drop that down to 4. All right. Now, what if I had not read the documentation for these things, and I just tried to assign the opacity to 50? Well, here you'll see what the new, more precise error messages look like. So here, I'm not only detecting that the value needs to be a number, but also even validating the range itself. So if I get an error message telling me that this opacity is invalid because it needs to be a number between 0 and 1. Or here's the case if I'm evaluating a enumeration property. So this hover mode is an enumeration property with a few valid values. I'll try to set it to nearest and get this error message telling me that it's an enumeration value. These are the valid values, x, y, closest, and false. So I can immediately understand that I've misremembered the property name, so I can copy this and change it to closest, because that's what I meant. For marker color, there are a lot of ways to specify colors, and the named CSS colors are supported. So I'm going to try to set this to color of these points to fuchsia. And I get this error message telling me all the valid ways to specify colors. And as I scroll down, I can see that I didn't spell fuchsia properly. So I'll copy the correct spelling and then make the update. And then I get the update right away. And then if I decide I don't want to use future after all, you can always go back to the default values by assigning none to the property that was overridden. So I assign the marker color back to none. I'll go back to the default value that Plotly.js chose. All right. So another way, helpful way to get a handle on distribution density is to use the histogram 2D contour trace. This is another trace type that Plotly comes with. And I can do that, add it to the existing figure. So I can look through all of these supported trace types by triggering completion on the figure object and with add underscore. And here's the list of all the trace types that Plotly supports. It's a long list here. I'll accept completion on histogram 2D contour, shift tab to pull up the documentation, and I can read about this trace. I can read about what the important properties are. In this case, I want to just pass it the same x and y values I gave to the scatter plot. So it'll show me a density contour plot for those same points. And there we go. I can look at this contour trace object and explore its properties interactively. So I'd like to change the color scale, or look at what color scales are supported. So if I trigger documentation on the color scale property, I'll get a list of the ways to specify color scales. So here's a list of named color scales you can use, or you can specify a custom one. So let me grab one of these named ones. I'll grab hot. And the color scale updates. That's a bit dark, so I want to flip it around so that the white region is the low density region. And then I can see a nice complement to the points to have this dual set of information. I'm going to set the hover info to skip. That way I'm not getting extra hover info on the contour trace. I'll only get the hover info on the points, which is what I want in this case. And I mean, I like this a lot. I like having the ability to see the outliers and see the distribution and see the smooth all at the same time. But to do this, you really need to have the opacity and the point size dialed in so you can make sense of both. So here I can make some adjustments, and maybe that's a little bit too opaque, a little smaller. And I can kind of fiddle with this until I get a view that I feel like represents the, lets me see the information that I want. But when you find yourself doing this kind of thing where you're adjusting properties and running a cell and trying something else and running it again, that's a good clue that you could use ipywidgets to help you with this. So I'm going to write a little function here that performs this same operation, just called set opacity. It inputs the opacity and size I want, and then performs the assignment. And then I can wrap that in a call to the interactive function from ipywidgets. I pass in my set opacity function, and then the range of values I'd like to be able to sweep over. So these are the range of opacities, the range of sizes I want to be able to sweep over. And then this produces a new widget. So I get this little control panel that I can use now to interactively in the notebook as I'm looking at my data to adjust the properties. So as I'm zooming in or panning around, I can just have this off to the side to help me understand and see this data set more easily. And let me adjust the properties on the sliders, make them a little wider, and there we go. All right. So next I want to look at the outliers. So this data set has a nice tight distribution with outliers kind of on both sides. In particular, there are some down sort of in this heel region that I want to look at. I can change opacity again so I can get a better look at them. So I'd like to understand what these points are. One helpful way to start this is I can adjust the tooltip. By default, the tooltip gives you the information about the x and y properties that you gave to the trace, but I can customize that, and I'm going to customize it to display the car ID from the original data set. So now when I hover over, I'll see the name of the vehicle that are these outliers. And that's really helpful, but there are a bunch of other properties that were in the data set that are more than just the name, and I'd like to see all of them and have a way to scan through this data set and see all the properties of the outliers to try to make sense of what's going on. One way to do that is to use an HTML ipywidget. So here I'm going to use another widget called HTML. I'm going to initialize it with a simple HTML string to show you what it looks like, how it again displays itself as an HTML representation. But then I want to override that with an HTML table representation of all of the points that I'm hovering over. To do that, I'm going to create a new function called hover function, and I'm going to register that function with the scatter trace. I'm going to use the onHover callback mechanism. This is saying whenever a hover event happens on this trace, run this function for me. So I'm going to run the hover function. What the function will do is grab the indices of the points that were involved in the hover event. It'll take those indices, find the location in the data frame, and and then convert that to HTML. So this is all a pandas expression to look up the row in the data frame and make an HTML table out of it. I'll assign that HTML table to the HTML widget, and then I'll show you what happens. So now, when I hover, I can see all of the properties. I can see the index of the point and all of the properties of the points that I'm looking at. And then I like to do the same thing for the image. So now I'll use an image widget to display, again, let's start out with the 2012 Camaro Coupe. And then I'm going to slightly update my hover function to now do the HTML table update as before, but then update the image widget as well with the same point. So now, after I run this update, I've overridden the old hover function with this new one. And now, when I hover, I get to see all the vehicle types. And it looks like there's a lot of conversion vans down here. And at the same time, my HTML table is also still updating. So this is, I mean, you can keep these widget components spread out throughout the notebook and just pull them off to the side when you need them, depending on what you're using them for. But it's also easy to pull them all together into a little notebook dashboard at the end. So here I'm just using the container objects from ipywidgets. HBox and VBox let you stack widgets together and make a larger collection out of them. And there we go. I have this little in-notebook dashboard that I can use to explore this data set, change properties, and the goal here is that this wasn't a large software development effort. This is just part of the analysis process. This isn't a dashboard that I want to use for every data set. This is one I wanted to use to look at this particular one. And what I think is exciting is that once you learn a few of these ipywidget conventions and how to update figures, you can make these in the process of just looking at data as part of an analysis workflow. I think that's a pretty powerful workflow to move into. The next one I want to show you is an example of responding to data selection. So here is another data set. This is a slice from the Gapminder life expectancy GDP per capita data set. This is a slice from the year 1982. So I started off with just a scatter plot, life expectancy for countries, GDP per capita on the y-axis in log scale, and then markers are sized with an area proportional to the population of the countries. And then the tooltip shows me the names of the countries. Then I'll also make a choropleth. This is another built-in plotly trace type, where I have a different region colored in for each country. Here I've initialized both of these to be colored in gray. And then I'm going to install a selection callback. So here for each trace, the scatter trace and the choropleth, I'm going to install this callback to be run when data is selected. And that will update the coloring of both traces and update the selection information, which will highlight the newly colored areas. Now run that and then put that in a little stacked dashboard again. And now I can do investigation of regions of this space. So I'm going to start with selecting this area of high income, high life expectancy countries. And I can see where those are distributed across the world. Or if I do the opposite, I'll look at the lower income, lower life expectancy countries and see where those are distributed across the world. Or the choropleths in Plotly actually also support selection. So I can select the countries across the continent and see their distribution in this life expectancy GDP per capita space. So this was, again, you saw all the code to wire this up. And you can do your own custom interactions based on these events. So you have a lot of flexibility in how you want to build up these little control panels to help you explore your data set. OK, I'm going to jump back to my slides. And talk about what's happened since version 3. So since we released version 3, here are some other things we've been working on. So Plotly.js has for a long time supported Latex typesetting in figures. It's using MathJax under the hood, the same engine that's doing the LaTeX typesetting for the Jupyter Notebook. But it hasn't worked well before in the notebook because there's a lot of complications going on with using MathJax for different things at the same time, a lot of global state that took a lot of work to sort through. But we have sorted through it now, so you can use LaTeX typesetting on your labels inside the Jupyter Notebook. And if I have time, I'll show you what that looks like in a few minutes. We've added theming support. So now it's possible to configure what you want the default properties to be across a particular figure or across all the figures in your session. So we're shipping with a collection of predefined themes, but then it's also possible for you to find your own themes, and they have a lot of options. In addition to like setting the colors and font styles, you can also do things like setting default labels on figures. So you could put like confidential on top and bottom, or you could put a watermark company logo on the side. So you can set these up to, you could like build them up, you could put them in a Python package, import them, and then all the figures you make in that session could follow that theme. The next one I want to talk about is a programmatic image export. So this is a really complicated problem for JavaScript-based visualization libraries, how to convert your nice interactive diagram into a high-quality static image, because you need a browser to do the rendering somewhere, and browsers can't write to files directly. So there's a lot of considerations here. The solution that the Poly team came up with, I'm really excited about. It's based on Electron. So we're using a standalone Electron executable to do the rendering into an image. And we've been able to package that Electron program called Orca using both Conda and NPM. So you can Conda install all the dependencies you need to do static image export. And it doesn't rely on WebDriver. It doesn't rely on a system browser being installed. It's all self-contained. And we've added a collection of new trace types. So here is a bar polar trace type. There's a bar chart in polar coordinates. And this is also very interactive. It supports you can do things like zooming. You can rotate stuff to help you hone in on the information you're looking at. And this complements existing support we already have for polar scatter plots and polar line charts. There's a new diagram that, called the parallel categories diagram. This is a visualization for multi-dimensional categorical data sets. And you can think about it as a discrete or a categorical analog to the parallel coordinates diagram, where your columns represent dimensions, and then the rectangles within the columns represent categorical states. And the height of these rectangles lets you see the relative frequency of the different combinations of states in your data set. We've added a 3D cone chart. So this is what you can use to represent three-dimensional vector fields. So zoom in here. You can see this is, again, WebGL accelerated 3D chart type that lets you show these directionality of a vector field. And then finally, a 3D stream tube chart type. This is a really nice way to look at continuous flow spaces. You can look at these stream tubes to understand the flow of a continuous space. And these two new 3D chart types, they complement the existing support that we have already for WebGL accelerated 3D scatter traces, 3D lines, 3D surfaces, 3D meshes, and 3D ribbon charts, or ribbon surfaces. All right, I have a couple minutes left, so I'm going to jump into these last two demos quick. So here's what the themes support looks like. So I'll create the same, use the same data set to create a bubble chart. Here I've used a separate trace type, or separate trace for each of the continents, so I get a different color cycle through the different continents. This is the default colors that PolyJS uses. And I can look at this templates object now to see a list of the available named templates that come preloaded with poly.py. So we have a Seaborn inspired template. We have a ggplot2 inspired template. And then a collection of new original templates based on some of the colors we like for Plotly stuff. So this is the Plotly template. It uses some of the gray background. This is a new color palette of points for the different traces. Plotly white uses the white background, but a similar color palette. And then if anyone here is a dark theme fan, Jupyter Lab comes with a really nice dark theme. But it always bothers me looking at white plots on a in dark theme. So we've added a Plotly dark template type that I think looks really nice when you're working in the Jupyter Lab dark theme. All right, switch back to standard theme. You can mix and match your templates. So presentation is the name of another template that is included, and this has the job of increasing the font size of all the elements of the plot. It also increases the line width of line traces. This can be combined with other theme types. So I can combine presentation with the Plotly theme I showed you above and get both of these applied. So now I have the font size increased, and I have the styling I wanted from the Plotly presentation plot, not the theme. And then one last one is this Xgrid off theme that has the job of only removing the Xgrid lines. So I can combine these three together and get a cleaner looking scatter plot where I don't have the Xgrid lines added as well. And then static image export. So all you need to do to add static image export is to run a conda command like this, where you're installing the Plotly Orca package and the psutil package. And once you've done that, you can use the write image function from the Plotly IO package to output these images. So there I just outputted these the same plot into 6 different image formats. I'll show you what that looks like over here right in Jupyter Lab. We have raster formats for PNG, JPEG, vector formats for SVG, and even PDF. So I can zoom in on this PDF, and you can see this is a true vector format image. All right. Last thing, I'll show you a quick example of the Latex support. Oh, and before that, I can show you, this is how you would set a default theme to use across your entire session. So if you set this template's default value to the name of a theme, this will now be automatically applied to any figure you create if you don't override the theme later. So I'll do this once at the top of the session, and then now when I create a new figure, it'll automatically use the new Plotly theme. So to use LaTeX in Plotly, you surround strings with $signs, and everything inside then is treated as LaTeX. It's past the mathjax. Mathjax does its thing, produces an SVG, and we do a lot of subtle things to put it in the right place. And then this also works with the figure widget support. So now I can update labels interactively, and they just work with LaTeX. And it also works with some of the export options. So now I can output this figure with the LaTeX type setting to a standalone HTML file. And I can then email this to someone and have the type setting preserved. And finally, this also works with the image export. So here, I'm going to export this figure to a vector PDF form, save it to disk. I'll open up LaTeX figure PDF, and I have a figure with a theme with LaTeX typesetting that is fully vector formatted in this figure. So this is a publication quality static image that was made from our interactive visualization library. And that is our setup of highlights. So if you want to learn more, and come talk to me, of course, but I've also pinned some links on my Twitter account. If you look at my account on Jon Mease on Twitter, I have a post pinned with a bunch of links to, we've done several blog posts. The 3.0 announcement post goes into a lot of detail in what I showed you in the first demo with the validation and the widget aspects. The paper from the proceedings, if you want to know more about how ipywidgets works underneath and how we used it to get this synchronization worked out. There's a whole post on how the static image export works with the Orca integration. There's a whole post on how the themes integration works. And then there's a link there to the main PolyPython documentation. And I just want to call out, finally, 2 other Plotly open source projects that are related to Plotly.py. First is Dash. So Plotly.py and the ipywidget approach that I showed you is really great for doing the exploratory phase and for quickly making widgets, quickly making things to help you look at your information in detail. Once you know how you want to present information and how you want to explore this type of data, Dash gives you the tools to create really sophisticated web applications based on more sophisticated widget types that's based on React. So you have a much larger suite of components that you have access to. You have full access to the HTML structure, you have full access to CSS, so you can really have pretty unbounded flexibility in making web applications, still totally in Python without writing any JavaScript. If you're interested in that, Chelsea has a talk in, I don't know, a couple hours on Dash. And then the Jupyter Lab chart editor is a new project we've just released that takes the graphical chart editor that Plotly has used in its online products for a while. There's a new version of that editor was released as an open source editor, and now we've integrated that into Jupyter Lab. So you can use that directly from the Jupyter Lab file menu to open figures in the graphical editor, edit them, make changes to them, add annotations, and then save them back out again in a GUI workflow. So if you're interested in that, come talk to me, or you can check out that project as well. And with that, I'll take any questions.
Question.
Yes.
Your example notebooks, are they in a GitHub someplace that we can get to them and play with them?
Yes. Yeah, they're on a GitHub on my account. I think that link is also pinned on my Twitter account. If not, I'll add it to. But yeah, those are up there. Yes.
Does the vector export, like SVG and PDF export, work with 3D?
It works, but the 3D stuff is rendered on the GPU, so those become raster embeddings inside the figure, so you don't get the true vector scaling for those.
Would you get something?
Yeah, it goes into vector. I mean, SVG, you can put PNG stuff inside it, and that's kind of how it goes for the stuff that's rendered on the GPU.
When you showed the export to HTML, does it retain the interactive components?
It retains the hover and click part. The callbacks that require Python won't be maintained. So you can still set up the interactions for displaying, like zooming and panning and hovering over things and getting the tooltips. All works, but the Python code won't be there. All right, well, come find me if you have any other questions or want to chat about ideas. But thanks for your time.